Speed and velocity adds on to our discussion of motion in general. We've talked about distance and displacement, and now we need to use those concepts to talk about what speed and velocity is. But before we can get there, since we've talked about distance and displacement already, we need to introduce the terms scalar and vector. Now, if you're using your notes from this year, it's not in there. I'm going to change this though, so this may be in your notes when you watch this video. Let me show you where I want you to write this stuff. Your notes on speed velocity, we're going to get here in a second. I can go ahead and tell you, let's go ahead and cross this out. This is redundant from what we talked about from distance and displacement. With your notes, that may not actually be there. We're going to do a Susie Snail's problem. That's going to take up about this much room. Scalars and vectors I want you to put down here in this space. Very simple concept. Basically, every single quantity we will talk about in this class, every single measurement we take, every single variable that we calculate is going to be either a scalar or a vector. So let's talk about what those are. A scalar is a quantity that has only magnitude. There's magnitude only. Again, you're just going to have to write these things. A lot of people have trouble understanding what the word magnitude means. That's just simply a number. If there's an earthquake, they're going to report the magnitude of that earthquake. That's like the size of the earthquake. And that number, that size will be given in the form of a number. So magnitude is something in which we report only the number. So I want you to know some examples of scalars, and we'll talk about those in just a minute. But a scalar quantity has only magnitude. We only report the number. We do not report direction, as opposed to a vector, which does have direction. In a vector, we report both magnitude and direction. In a vector, we report both magnitude and direction. So remember the vector video that I showed you in class where he is sitting next to Gru and he said, I'm committing crimes with both magnitude and direction, or direction and magnitude. Does he say it in that order? Maybe so. But a vector not only has magnitude, but it has direction. These are things where the direction makes a difference. Okay, so let's talk about some scalar quantities. We talked about distance already. When I ask you how far it is to the grocery store, you're not going to give me the direction because I just care about the number, the distance. How many miles am I going to put on my car? Speed is another one. We're going to talk about speed in a minute. Speed is a scalar as well, so write that down as an example of a scalar. If a cop pulls you over and he says, do you know how fast you are going? It would be kind of strange if you said 80 miles per hour west. He knows what direction you're going. He didn't ask for that. He didn't ask for your velocity. He asked for your speed, which is just a number. All these other things are scalar quantities. Mass, we just report the number. Time, density, work, energy. Temperature is another one. We just report the number. That's a scalar. Magnitude only. Vectors, there are some vector counterparts of some of these. There's a vector counterpart of distance, and that is displacement, because when we report displacement, it's the distance plus the direction. Okay, so displacement is a vector. Velocity is the counterpart of speed, the vector counterpart of speed. So if the cop asks you for your velocity, technically that includes direction as well. I don't think cops would actually do that. But velocity in this class is speed and direction, the magnitude of whatever it is we're talking about and that direction, because direction is important. Time to go to class, or should you be in class by now? Figure that out on your own. Acceleration is another vector quantity. Force is a vector because it matters what direction you push. If you want to move a couch across the room, you got to know what direction to push it. All of these things are vector quantities. So that goes down there at the bottom of your notes. That's all I have for scalars and vectors. Now let's go ahead and go back up to the top and let's talk about speed. All right, definition of speed. This is really hard. It's hard to understand, right? Speed is how fast something is moving. Ooh, really hard. Yeah, you already knew that. That's super easy. How fast something is moving. Now what people usually don't understand is the fact that speed is always a positive number. And they're like, why is that? Because remember I told you that I can actually go negative 30 miles an hour. And a lot of people don't understand that, but remember that negative and positive in this class means direction only. And when I say here that it will always be a positive number, that doesn't mean that there's going to be a positive in front of a speed. That means really that there won't be a sign in front of a speed. And the reason is because speed is a scalar. We only care about the number. So speed is how fast something is moving. It's always a positive number. We're going to skip average speed. We're going to skip instantaneous speed. I'm not going to have you worry about that. But right now, I want you to write this equation, and I actually want you to write it in your notes right here. The equation for speed is the one that we learned the other day in the lab when we did the car activity. V equals d over t. Speed equals distance divided by time. Now, the reason I tell you this is because we need to manipulate this equation to solve for all of the other variables. And that's true for every equation in this class. For instance, you'll have a problem in the homework that asks you to solve for the distance, and a lot of people get confused and they come up to me and they say, Mr. Valls, there's no equation for distance. And what they mean is that there's no equation that says distance equals whatever. This is the equation for speed, technically. But because distance is in the equation, you will be expected to know how to solve for distance using this equation. You need to be able to solve for any and all of the variables in any of our equations. So you can do that using algebra. If you're good at algebra, that's great. If you're not, there's a shortcut that your teacher may have taught you, your math teacher, and that's the triangle method. And basically what you can do is, if you can imagine a triangle right here on top of this equation, what I would do is something like this, and then the D would be at the top of the triangle, the T and the V at the bottom. And if you want to redraw that to make it look a little bit better, triangle looks like this, V, D at the top, T. So basically how we use this triangle is whatever variable you're trying to solve for at the moment, you just kind of cover that one up, and the other two tell you what to do. So if I'm trying to solve for V, as this equation says, V equals D over T, distance divided by time. Maybe I want distance, cover that guy up. Distance is V times T, velocity times time, and you can probably see that from the equation if you know algebra. I want T, cover that guy up, distance divided by speed. Again, you can probably see that from the equation if you know algebra. Time is the one that people usually have the most trouble with, though. So you need to know how to do this. You need to know how to manipulate this equation and all of the others to solve for all of the variables in this equation. Let's go back up here and finish the notes on velocity. So here we go, velocity. Speed again is a scalar. Velocity is the vector counterpart. Velocity is the speed, same thing as speed, but now we're going to report the direction, speed with direction. And the direction, remember, we talked about this before, is just expressed as a positive or negative. In this class, when we say positive, that means up or to the right. Sometimes if it's a car or walking, we might use forward for that. We might use backwards for negative. Negative is down or to the left. So that's what direction really means. Okay, so that's all I really want you to know about velocity. I don't care about average velocity. Don't care about instantaneous velocity. In this class, not that big a deal. So let's move forward. Again, we're skipping that section on distance and displacement if that's in your notes, because this section is not about distance and displacement. I want to go all the way down to the bottom now, and we'll talk about Susie the snail. We got Susie Snails. She's driving at 60 kilometers per hour, talking to her friend Ned Nugget on the phone. These people have really cool names. Yeah, I guess they're not people. Susie Snails would be a snail. Ned Nugget, maybe he came from Chick-fil-A. I don't know. She's on her cell phone. She shouldn't be on her cell phone while she's driving, by the way. Public safety announcement. She suddenly notices a red light. It takes her 0.75 seconds to react to that red light, because her reaction time is very slow because she's on her phone, not to mention the fact that she's a snail, which makes her that much slower. Anyway, how many meters will the car travel before she hits the brakes? So, first thing I want you to know is that in this class, I'm going to give you all of the correct units that we need. There won't have to be any conversions at this point. So when I say kilometers per hour, I actually just want to change that, and we'll make that meters per second, because every time we work with speed and velocity in this class, the units have to be meters per second. I'm going to begin to teach you a method of solving problems in here. I'm going to be more specific about it when we get to acceleration, but basically, here's the deal. A lot of people read these word problems and they can solve them very easily because they just think that way. Not everybody does, though. And so for those people that have a little harder time with this, here's all you really need to know. Word problems always work out for you if you know basically three things. What are they giving you? What are they asking for? And what equation has all those things in it? If you know those three things, you're well on your way to solving this problem. So if you can read this problem and tell me that the 60 meters per second is the speed, you're doing good. That is her speed. Meters per second is always a speed. That's the unit for speed. You read this problem and tells me 0.75 seconds. That's the time. That's how long it takes her to react. Seconds is a unit for time. How many meters will the car travel? They're asking us for distance. You need to know that like there's certain questions that will be used, words that will be used to ask for distance, like how many meters will the car travel, how far will the car go, things like that. What is the height? All of that is just distance. Okay? So I know what they gave me, I know what they asked me for, and voila, wouldn't you know it, the equation that has those three things in it is the one that we're talking about together. Wow, it's amazing. So we simply write down the equation. That means no numbers yet, very important. And then we plug in 60 for V, because that's what we got. We plug in 0.75 for T, and the D stays the same, because that's what we're looking for. Don't replace it with anything else. Don't put a blank, don't put an X, don't put a heart. Keep it a D, because you know that's what you're looking for. Algebra. Handy dandy triangle says if we're solving for V, we do velocity times time. That's what our algebra would dictate as well. We would multiply by 0.75 to get rid of it on this side, do the same thing on both sides. 0.75 times 60 gives us a distance. 3/4 of 60 is actually 45 meters. She travels 45 meters before she actually begins to hit the brakes. And then there's going to be some more distance that's covered after that. Bad idea, Susie Snails. Let's talk about one other problem. I'm just going to make one up here. So find some dead space to do this if you want. Let's just say we have a horse, and that horse is traveling at a speed of 35, let's say 35 meters per second. And I want to know how long it takes that horse to go a distance of 185 meters, right? How long is it going to take this horse to travel 185 meters? If this is what the problem says, same thing. What am I given in this problem? Well, this is my speed. Speed is 35 meters per second. This is my distance. Bad writing. That's my distance. Distance is 185 meters. I want to know how long it's going to take this horse to do this. Time is what I'm solving for. So here we go. Same equation. V equals d over t. I'm going to plug in the numbers that I know. V is 35. My distance is 185, and the time is what I don't know. Keep it a t. This right here is surprisingly one of the most common algebra mistake I get in this class. People don't know how to solve for t. So that's when our triangle can come in, cover up the t, distance divided by velocity. But it's difficult to see that just by looking at this equation. Here's how I do this with algebra. Just know anytime we have an equation with this format, which is basically a fraction equal to a fraction, has to be this. And I say fraction equal to a fraction because, remember, there's an understood 1 under here, so technically every whole number is a fraction. All we need to do is really cross multiply. So that's this times this, this times this. 35 times t is 35t. 185 times 1 is 185. That doesn't get us the answer, it just gets us a new equation that's a lot easier to work with. And now we can see that we would divide by 35 on both sides. Gets rid of it over here. To solve for t, it's 185 divided by 35. There's a shortcut to that. Basically, what I know and what I'll tell you is that when you're in this situation, every time you need to solve for the thing in the denominator, the result of cross multiplication, look what happened here. We just took this 35 and we brought it down. See? And we took the t and we brought it up. In other words, the result of cross multiplication, let me write my equation again. The result of cross multiplication when you need to solve for the thing on the bottom is these guys switch places. That's it. So when I'm looking at this, I know enough to know, oh, switch places with those, 185 divided by 35. So let's run those numbers real fast. 185 divided by 35 gives us 5.285, 5.29. Let's just call it 5.3. Takes the horse 5.3 seconds to do this. So there's a problem about time. Well, solving for time using the v equals d over t equation.